Welcome to the online class for BSc 3rd Sem, Session 6, Network Theorems. In network, in this network theorems, we shall discuss about a current and voltage divider rule in this session. The learning objective of this session is to analyze linear electrical networks and to find out current and voltages across each branch. The session outcomes is to identify the nodes and loops in a given network and to state a current divider rule, state voltage divider rule, and use the current divider rule CDR and voltage divider rule VDR to analyze a simple electric network. Prerequisites of the session is one has to know about charge, current and voltage, and Ohm's law, and internal resistance and equivalent resistance, and series or parallel combination of equivalent resistance. The terms used in the session is network. Network is another electrical network is a system of interconnected electrical components. And if a network consists of only a source and linear circuit element like a resistor, capacitors and inductors, it is called as a linear network. And the second term used in the session is node. A node is a electrical network is a point where two or more components meet. And the next concept is a loop. A loop is an electrical network is a closed path going through the circuit elements. These are the terms used in the session. Okay, this let us understand the current and voltage divider rules CDR and VDR. The statement of the current and voltage divider rule. First, we shall discuss about the current divider rule. Current divider rule is the electrical current entering the node of a parallel circuit is divided into branches. It is also defined as current divider rule is employed to calculate the magnitude of the divided currents in the circuits. It is called as CDR. Similarly, voltage divider rule, the voltage across the circuit is divided among the branches of each resistances connected across the voltage source. The voltage divider rule is employed to determine the voltage across the resistors connected across the source. These are the statements of the current and voltage divider rule. Here voltage divider rule is there. Voltage divider principle is voltage divider circuit are used in electronics to supply a range of voltages needed by the system from the signal sources. The voltage divider uses the principle of Ohm's law to generate the necessary voltages. In figure, the V is node connection, Vt is equal to E into R2 divided by R1 plus R2. Vt is loaded conditions, I load is much less than Is. IR, Vr is equal to E into R2 divided by R1 plus R2. For good stability, current I must be at least 10 times that flowing in the load. Similarly, current divider rule. In a parallel circuits, the current IT divides up through the various branches network I1 and I2. The ratio between the any two branch currents is inverse ratio of the branch resistance. Therefore, I1 is equal to IT into R2 divided by R1 plus R2. In figure, you can observe that I2 is equal to IT into R1 divided by R1 plus R2. This procedure is only suitable where there are two parallel branches are there. And the recapitulation terminology: equivalent resistance, series and parallel combination of resistance, current. Within this session we discussed about the current divider rule and voltage divider rule. Okay, the multiple choice question. Find out the currents I1 and I2 in the following circuit. Okay, option A 6.66 amperes, 13.33 amperes. Option B 12.33 amperes, 6.66 amperes. Option C 13.33 amperes, 7.66 amperes. Option D 13.33 amperes, 6.66 amperes. The answer is option D 13.33 amperes, 6.66 amperes. And next multiple choice question. The electric current entering the node of a parallel circuit is divided into branches is called as voltage divider rule. Option B, current divider rule. Option C, Kirchhoff's law. Option D, none of the above. Answer for this question is option B, current divider rule. Question number 3. Three resistive elements of 6 kilo ohms, 12 kilo ohms and 18 kilo ohms are connected together in a series across a 36 volt supply. Calculate the total resistance, the value of the current flowing around the circuit and the voltage drops across each resistors. The options are A 6 volts, 12 volts, 18 volts. Option B 12 volts, 6 volts, 18 volts. Option C 18 volts, 6 volts, 12 volts. Option D 12 volts, 18 volts, 6 volts. The answer is option A 6 volts, 12 volts and 18 volts. In the figure, find out the voltage across the resistance R3. Okay, option A 7.88 volts, 9.66 volts, 6.66 volts, 5.66 volts. Answer is option C 6.66 volts. Okay, these are some of the references. Halliday, Resnick, Walker, Fundamental of Physics, India, JWS 2002, and Mehta VK, Mehta Rohit, Principles of Electronics, India, SCP. The images are downloaded from the SlideShare. Thank you.